Okay, podcast 1.6, talking about density. This is the last podcast of our unit. Yay! But that means that the test is coming up, so let's get to it. We are going to be covering page 20 all the way from the top to the bottom. I'm not going to finish the last question, but you better finish it if you want your stamp. So, we're going to start by defining density. If you looked up the definition of density online, it might tell you that it's a ratio of mass per volume, which is great and it's true. But what does that mean? Well, that means that density is measuring how tightly packed our matter is. How much stuff, our mass, is packed in a certain amount of space, the volume. That's all it is how compact our matter is. And bringing this back to our states of matter, solids tend to be the more dense state of matter than the liquid or gas version of the same substance. So liquids are a little bit less dense, and then gases tend to be very, very low densities. But that's just a general rule. There is actually a pretty common exception, but we'll talk about that later when we start studying gases. So, we're not just going to be defining density, we're going to be calculating it. So, here is our formula. Density is equal to mass divided by volume. Now, important note, mass is generally going to be measured in grams. You might see it as kilograms. Volume is going to be measured in milliliters, and possibly you might see that as centimeters cubed. It's a weird-looking unit, but milliliters is like pouring a liquid into a graduated cylinder. It'll give you milliliters. If you were measuring a solid, though, you'd have to measure the solid's sides and do length times width times heights. And that will get you measure that in centimeters, which we should as scientists. Centimeters times centimeters times centimeters gets you centimeters cubed. All of that saying is that both of those are possible units for volume, and the great thing is, no matter how complicated it looks, they're actually equivalent. 1 milliliter is equal to 1 cubic centimeter. So don't let it trip you up. If the centimeters cubed is really messing with you, just change it all to milliliters and you'll be perfect. So, density is what we're solving for, and density's units are going to look a little complicated because grams and milliliters won't cancel out when you divide them. So they're just going to combine together, and it's going to be kind of a fraction just like this equation is. Grams over milliliters. Or if you volume is in centimeters cubed, your units for density might be grams per centimeter cubed. Either way, those big complicated units are not another math formula or equation. It's just kind of complicated looking units for density. So, what are we going to do with density? Well, we can solve for it, but we can also use it as a conversion factor in dimensional analysis. So what I mean by that, in the first problem we're going to work, we have a density given to us of 19.3 grams per milliliter. If we break that apart, then that means that for this substance, we have 19.3 grams of the substance per milliliter. For how many milliliters? Per means for 1 milliliter. So this is one of our conversion factors that we can use. We're kind of just pulling apart that density and putting the 19.3 grams on one side of the equal sign and the milliliters on the other. And it's always going to be 1 milliliter on that side because these units are grams per milliliter. So, if you're given a density, you can use it as a conversion factor, and it might save you a whole lot of time and algebra and possible mistakes rather than using that density equation. But I'm going to work it both ways on the first problem, and we'll do a couple more, and I'll let you decide whenever you work a problem which way you'd like to do it. As long as you show your work, I'm fine with it. So, let's look at that first calculation that we're going to do together. This tells us that our density of gold is 19.3 grams per milliliter, like we said before, and asks what's the volume of a 15.5 gram sample. So, that means I'm looking for volume. I'm going to be looking for milliliters, and what I've got to start with is grams. Remember, this density is not going to be our given. This is going to be our conversion factor. We're pulling that apart like we did before, saying 19.3 grams per milliliter. With that, if I start with my 15.5 grams on top of my dimensional analysis process and line, in this next bracket, what I need to do is make sure that I have these grams on the bottom of the next bracket so that those will technically cancel out and get me my new units. So that means that the 19.3 is going to be coming down to the bottom with those grams, and the 1 milliliter is left on top. And then that's it. I've got the milliliters that I had wanted. So I'm ready to calculate. Remember, we do top divided by bottom. And when we get this answer out, calculator tells us it's 0.0803. And that just did not make that look more like a 3. And that is our final completely rounded answer, because my given here and all of the numbers that I put together were 3 sig figs. So I'm just keeping those 3 sig figs right there. I'm going to rewrite that just so that I can make sure to get my units on that with my box. So this is my full, complete, correct answer. Number rounded correctly with units. Pretty simple as long as you know what dimensional analysis is doing for you. Now let's do the same thing but with our density formula. So with that formula, D equals M over V, I know that my density is 19.3 and my mass is 15.5, and I'm trying to solve for my volume. Honestly, the quickest way to do this is to kind of do your cross multiplication thing. You know, if this side doesn't have an actual fraction, you can pretend like it's over 1, and then from there we cross multiply 19.3 times that V that I want to find is equal to 1 times 15.5, which is 15.5. In order to solve for that V, I'd have to divide by 19.3. After I do that, and this cancels out, then my V is equal to 15.5 divided by 19.3. But, isn't that what we had just done earlier? It looked a little different, but we had our 15.5 grams here, and our 19.3 grams were on the bottom over here. And that's all that we did. But it was a little bit simpler because the dimensional analysis got us there in one step instead of having to do this rearranging and cross-multiplying with our density formula. So we would still get the same answer one way or another. Don't worry about which way you choose. Just choose a way and make sure that you can get this answer. So let's take another example real quick. If I can get to the next one. There we go. Piece of metal with a mass of 147 is placed in a 50 ml cylinder. The water level rises from 20 to 41 milliliters. What's the density of the metal? Okay, when it's asking for density, the simplest thing to do is use our density formula. I know you could probably figure out a way to use dimensional analysis to do it, but we have a formula to find it. So when finding density, just use the density formula. So I saw my mass in there because I saw these grams. So 147 goes on top. Then volume. There's actually a few different volume measurements. It talks about the size of my cylinder, and then I put an object in my water. So I've got a cylinder with some water in it, and when I put my object in it, that water level goes up. So the object must have made that water level go up. Okay, so the difference between my initial and final water level must get me the volume of my object. And if it goes from 20 to 41, that must mean that my volume was 21 milliliters. So just stick that down there on the bottom, and 147 divided by 21, well, the answer the calculator gives us is 7. But that should feel a little bit weird to write down. And if we go back and look at things, I had 3 significant figures here and 2 in each of these. And we subtracted there, so we just kept the 21, which has 0 decimal places there. And so that was just 2 sig figs. But I still don't want to round down to just 1 sig fig. So we do need to make that 2 for this to be full and correct. And then density, We can choose either of our units, but because I did grams and I did divide by milliliters, then those are the units that I'm going to use. So that is my answer to number 2. Or I guess they're not really numbered. And one more, if we can get rid of this and move forward. Model boat has a mass of 1,300 grams. What's the minimum volume? So I'm solving for volume now in centimeters cubed in order for the boat to float in water. Hint, what's the density of water? Well, I'm just going to give it to you. Water's density, and I've mentioned it before, is 1 gram per milliliter. Let me make that look a little more like a G. There we go. So that means that if I wanted to do this as quickly as I can, 1 gram of water is equal to 1 milliliter of water. And if I want to find volume and I have grams, I'm going to start from that 1,300 grams, put the grams part of this on the bottom so that it matches, 1.0 grams, 1 milliliter on top. Milliliters is the volume that I want. So I guess I need to do 1,300 times 1, then divided by 1, and oh wait, that's 1,300. It just changed the units, but the value didn't change. And we know dimensional analysis is notorious for that, but that's the point, is for us to help get confidence and be sure of our conversions with our different units. So that's that problem. Pretty straightforward. This is the minimum volume that a boat would have to be in order for it to float. And they do have pretty big boats. This is a pretty small boat comparatively because it's a model boat. So that's basically it. This next problem on the page I'm going to leave for you to calculate. I will give you a couple of hints though, because there's none written on the board. It asks us for the mass, and it gives us the density. Remember, you can pull that apart into a conversion factor if that's going to help you get from one measurement to units to another. But if we keep looking, we don't really have any masses or volumes given to us. We do have these numbers though. Ooh, that's not helpful. Okay, fix that, back to it. We have these 3 numbers up here though, and each of them have centimeters. So this is like the sides of my block of lead. And in order to get something that maybe looks kind of like this with centimeters cubed, I might need to multiply all 3 of these centimeter measurements together, and that might help me calculate some kind of volume in centimeters cubed. And then maybe I could either use dimensional analysis to get my answer, or at least then I had to have something I could plug into my density formula. But one way or the other, this time you're going to be trying to calculate mass of this block. So good luck, and make sure you finish this problem if you want a stamp.